Hi YouTube. What we've got here is a nice Samsung 24-inch monitor. We're going to be taking a look at a potential repair to it. If you look down here, you'll see this blue light indicates that the monitor is on, but as you can see there's no picture. What you may just be able to make out faintly, there we go, you can just see there is a picture there. Calculator, sticky notes, snippets, paint. The monitor is working. It did work sort of for about 2 or 3 minutes. Switched it on, backlight came on, the monitor was working fine, nice clear picture, and then the backlight went off. That's essentially what's wrong with it. The backlight's broken. There is no light from the backlight at all now. Previously, if I unplugged it from the mains, left it for 30 seconds, plugged it back in again, it may come on for a little while, a few seconds or so. Now it doesn't come on at all. I'll just demonstrate. If I switch it off at the mains, it's off, there's no power to the display. Switch it back on again, it's on, nothing. You can still just faintly make out the outline on that start menu, but there's no backlight at all. So what I'm going to be looking at is trying to repair this. It's an older style LCD that uses cold cathode fluorescent tubes for the backlights. The older style, the CCFL cold cathode monitors are more prone to having backlight failure, and I believe that's because the backlights run on a very high voltage. The newer monitors that use LEDs are much more reliable and robust. But this monitor here, Packard Bell 1, is one that I've recently repaired using a kit that I bought off of eBay. Essentially, I was looking at how to power the cold cathodes separately. The power boards on the monitors fail, and what I was looking at is a way of getting power to them without replacing the whole board. Originally I wanted to see whether it was possible to swap power supplies between monitors, and then discovered that there were a couple of people online talking about repairing monitors using power supplies from cold cathode fluorescent lighting kits that you can get for PCs. A lot of people use them in cars as well. They run on 12 volts, you get a little power supply box, and they output enough voltage to run a couple of cold cathode tubes. When I went to look for one of these, what I actually came across was this little device here. As you can see from the slightly scary hazard labels there, caution high voltage. These are made in China, but there's a few UK sellers and it costs less than £6. And basically what it is it's a universal LCD backlight power supply. So simple looking board, couple of rather hefty looking power transformers on there, and the connectors, which are the standard connectors used for cold cathode lighting. I believe, as I said, this operates at about 600 volts. Takes in anywhere between, I think it says up here, 10, this camera's focus is a bit naff. Yeah, 10 to 30 volts. So, and then you've just got a little connector there, which is for this little wiring harness. Now, interestingly, the connections are both the same on either end of the cable, but they're wired backwards. So you've got to watch what you're doing. If you plug this one in here, that's the way up it goes. You'll see black wires on the left. If you plug the other end in, the black wires on the right. What I identified was that the first pin on the left was a positive one, this one. Negative over here. We've got 4 pins, positive, negative, and then we've got a signal on off that can be powered with a lower voltage, 3 to 5 volts, and this one here is an adjustment which is used to control the brightness of the lights. With this monitor here, what I did was just found 4 points on the original board, a 12 volt, a ground, 5 volt on off signal, and an adjustment, which were all labelled on the board, soldered the 4 wires onto it, and hey presto, it worked beautifully. So I'm going to attempt a similar repair here. My only slight concern is whether the 12 volt or whatever it is supply from the power supply is going to be able to put out enough current to run this, because I'm obviously not removing the original supply, but I would assume that the transformers aren't running anyway because they're knackered, and there may be some sort of cut off, I hope. It's more of a fun project. I wouldn't recommend that you go too crazy with this kind of repair. Obviously we're dealing with very high voltages here. This is a mains device. There's big capacitors inside that can hold high amounts of power that could be discharged into you if you're not careful where you're touching. Obviously don't have it running powered on with the back open, but I'm just going to crack it open now and have a look at what we've got inside. I will switch it off and unplug it from the mains first before I do so, and then I'll be back. Okay, so I've got the back off of the device now. There was only a couple of screws in it. Here's the back. It was around this way, and we literally just had 1, 2 screws and a lot of clips around the outside, and it's come off. I've removed the screws from the VGA and DVI connectors, and then this is where all the electronics are. Okay, so over this side we've got a couple of connectors which, if we pull out, disconnect, these are the actual cold cathodes themselves. Now what you'll see, this unit here is designed to run 4 cold cathode lights. The last repair I did on a monitor had 4 separate connectors. On this one they seem to be joined together in the middle. Now originally I thought I was going to have to cut them apart, but it turns out that they're exactly the right distance apart to fit into these connectors. So with a bit of luck I should be able to use this without any major modifications. But we'll get to that in a minute. So on this board we've got another connector here which unclips and pulls out. That's for the controls on the front of the monitor. And then we've got a little ribbon cable here which is actually taking the signal to the LCD panel. So again we'll squeeze that, pull that one out. Now once we've got those out, this unit isn't actually fixed in place. It was on the other monitor I repaired, but on this one it's not, so it literally lifts off. Flip it over and we've got some electronics inside here. We've got 2 boards. I'll just grab my screwdriver a second. So this is the power supply, the bigger one. Looks a bit dark in the middle. I wonder whether that's a sign of damage to it. Possibly, I hope not. So what I'm going to do, again be careful what you're doing here. Just going to remove these screws. I've got one here. Second one here. Some sort of grounding plate. Now I have already removed this, so I didn't put all the screws back. There's a couple more, but for the purposes of what I'm doing, I'll put it this way. Second board here has a single screw in it. Remove that one as well, and then we should be able to free these boards. Now this one here is our little signal processing board. It drives the LCD, DVI, VGA in, some rather clever gubbins there, and a ribbon cable going over to the power board. If we remove the power board, flip it over, I'll take that out of the way a second. Now on here you'll see we've got a couple of transistors, another one there, big capacitor there, some more capacitors, transformer. This is the high voltage circuit, and these are the outputs for the cold cathodes. This is the part that I believe is damaged. When I originally opened this up I was hoping to find some blown capacitors, or maybe obvious damage to a transistor, although saying that now, the area around here on the board looks a bit discoloured. I wonder whether this transistor's failed. Well, there's a fuse over here, that's on the AC side, so that's the 240 volts coming in. If that was gone the monitor wouldn't work at all, so we know that's okay. The rest of the capacitors look fine, so all I'm going to do is search for points where I can attach my new power supply board. There's plenty of space in here to mount this somewhere, over this side preferably, so I can plug the cold cathodes into it. And with a bit of luck we should be good to go. Looking at the connections on here, this is where the front panel comes in. We've got ground, key 1, key 2, LED 3.3 volts, so that's just running the LED on the front and the power from there. What we're really looking for is higher voltage. There's a couple of markings on here. Output, according to this, says 5.1 volts at 3 amps, 15 volts at 0.1 amp. Now that's my concern there. Underneath that it also says 700 volts, that's going to be the output for the cold cathodes, at 7.5 milliamps. So despite being a very high voltage, the current is very low. 7.5 milliamps is all, but it's 700 volts, so that's very high voltage. Give you a bit of a sting if you got that sent down your finger. There's even a warning here, caution high voltage. So what we need to do is find somewhere where we can get between 10 and 30 volts. Now the 15 volt output would be perfect, but it says 0.1 amp. I wonder if that's actually accurate, whether that only relates to this transformer or what. Down this end of the board we've got the pin outs for this connector, which is what I used on the other monitor I repaired. Now pin 14's ground, pin 3 and 4, 5 are ground, and then we've got 6 and 7 at 5.1 volts, 10 at 3.3 volts, 2 at 15 volts. Right, so pin 2 is 15 volts. That should be good to drive this. And we've got a couple of 5.1 volts, 6, 7. We've got an on-off on pin 9. I wonder if we can use that for the on-off signal. I'll try it. Ground's no problem, and then we need an adjustment. What does that say? ADIM 8. Pin number 8 is the ADIM. We've got BDIM as well. Not sure. On the other board it was labelled as ADJ. Adjust. But not to worry. Quite handily for Samsung because they are slightly better quality electronics manufacturer than Packard Bell. Although I don't believe Packard Bell manufactured that. They probably had some other firm manufacture it on their behalf anyway. The back of the board has the pin outs on it as well. So we've got 15 volt over here on this pin. Ground, offs over here. Okay, well I'm going to have a go at soldering these wires and see how we get on. There is what looks like a negative symbol on the final pin on the right, so what I'm going to do is I'm actually going to push that one in there, and then what I did for the other one was I cut the cables near to the end, so I'll do it now, and then I'll strip these and solder them onto the points, so I'll be back shortly. Okay, so I've soldered the wires on now. I've got the 15.1 volt attached to the positive, ground on the next, well, that's pin 2. Pin 4 I've got ground, and I've got that attached to a DIM, that's the adjust signal, and then on off signal there is what I've got attached to the on off signal for the board. Now I don't know if for certain that the board's going to operate in the way I expect it to, but it seemed as good a shot as any. So what I'm going to do now is pop these boards back in here, just for safety's sake, because I really don't want to get a nasty shock off of this. So I'll pop that one back in there, that one back in there, that in, I'll clip that wire in there. Okay, now what I'm also going to do is I'm just going to put a little bit of tape over this to hold the connector in place, because whilst it is soldered in, I'd like to actually take up a little bit of the strain without having to rely on the solder to do so. That should hold them nicely in there. Now this wire is going to come to the power supply. That's going to be on that way round. I want it to come out that side. Okay, now let's pop a couple of screws back in the board. Screw this board down first. Okay, that's nice and fixed, and then we will attach a nice big ground grounding screw here to this point. Make sure we're and then we'll fix this one in on here. It's a good measure. This actually clips in by the looks of it, so clip that one under there. Good. That should be enough to hold everything in place. So now if we flip this board over, we can see, so it's going to go, okay, so we need to feed this wire out that side. How are we going to do that? I think perhaps our best bet is going to be back out that hole there, I guess. Put another bit of tape on it to make sure that we're not going to be putting too much strain on this cable. This is only temporary until I know it works, and then I'll do a slightly more permanent fix, but just for the minute. Okay, so we can pop that back on there, and then we plug that one in for the front panel controls, or side panel, or whatever you want to call it. I'll plug this nice chunky ribbon cable back in to drive the LCD panel. And then I'll wire up these cold cathodes. That one's going to push in there. That one's going to push in there. And because this is all neatly wrapped in plastic, I'm not too worried about shorting any of the electrical contacts like that. So that's plugged in now. It should be live when I power the monitor on, providing that that on-off signal actually provides voltage to switch this board on. So again, a little bit of tape just to keep this board in place for the moment. Just while I'm testing it. Put another strip on it. Okay, and now should be good to test. What I'm going to do is just pop the back of the monitor panel on loosely, just to make sure that the worst of it's covered up. And then I will flip it up like so. And then what we need, just switch the soldering iron off, is a nice 240 volt feed. There we go, here's our kettle lead that we were using our last test with. Pop that one in there. And what we should be able to do when we switch this on is see whether the backlights come on without a video signal. Right, we're in, switch on. Okay, well, it hasn't exploded, that's a good start. And you should be able to see here we've got a flashing digital analog signal up here. Now what that tells me is that the backlights are on. The fact that we've got a picture there is very positive. So let me grab this. There we go, check signal cable analog. Quite nice and clearly lit. So let me plug this VGA signal in. This is connected to a laptop which I believe is on, so we may even get a picture straight off. Or it may just go to sleep. Let's wake this up. Hey, there we go. That looks pretty good. We've got a picture. Let's see if we can. Let's just see if the on-screen display buttons work then. Menu. So, right, so we've got a menu now. Oh yeah, I was going to see if I auto adjust works. Okay, if I switch it off, does the backlight go off? It appears to. Doesn't look like it's being lit. That's good. That would suggest the on-off is wired correctly. So the only other one is the brightness. So that is brightness control, I believe. No, it doesn't work like that, so I have to hit enter, and now I'm on brightness, and then I can go up. Nope. Come on. Adjust up and down. Okay. Up. Okay, doesn't appear to be getting any brighter. We'll go down. Not getting any dimmer. Oh, there we go. It did get slightly dimmer.